All right, you guys, so this is using the zero product property and factoring. Okay, so first off, you guys already know the zero product property, but basically we just like to spell it out. So the zero product property says if A, B, and remember these are just two variables, if A, B, and that means A times B, right? If A times B equals 0, well then it should be pretty obvious that either A equals 0 or B equals 0, right? Because any two numbers, if we multiply them together and we get 0, one of the numbers must be equal to 0, correct? So we're going to use that property in order to solve these harder kind of problems. So let's take a look at example number 1. Example number 1 says solve, and if we notice, we have these binomials and they're being multiplied together. So usually, or what we've been doing is we've been multiplying them together and getting a big, huge string of numbers, right? Or what we call a quadratic. So if I were to do that, it would just make more of a mess for me, because if I see that I get this right here, I have this number, it's just some number, times some other number, and that equals 0. Well, that's kind of like saying that this is my A, and this is my B, right? And the zero product property tells me that if I'm multiplying two numbers together and I get 0, well, one of them must be equal to 0. So instead of multiplying them and doing my FOIL or using my box, what I'm going to do is I'm just going to split them apart. I'm going to say, well, either x plus 3 equals 0 or x minus 2 equals 0. Okay? And then I just have to solve each one of those. Well, I see here all I have to do is subtract 3, and I get x equals negative 3. And here I just have to add 2, so I get x equals positive 2. And these would be my two answers. Okay? Of course, I would always, when you're doing this, suggest plugging in your answers and making sure that they make sense. So let's do that real quick. If I plugged it in, I get negative 3 plus 3 times negative 3 minus 2 equals 0. Well, negative 3 plus 3, that's my 0. And again, I'm multiplying it times negative 5, but 0 times any number is just 0. So that one checks out. Let's check out the positive 2. I get 2 plus 3 times 2 minus 2. And again, I get 2 minus 2. Well, that's just 0. And anytime I'm multiplying, doesn't matter whatever the number is, if I'm multiplying it times 0, I get 0. Okay? Even if you multiplied these out and got your quadratic, in fact, just to make sure that we know how to do that, why don't you go ahead and do that on your paper. Multiply this out and plug in both of these numbers. And if you do it correctly, you should get zeros. So when I check the notes, I'm going to check that you did that. Okay? Moving on to some other types of problems, we still have to go over factoring. Okay? So factoring polynomials. So when we're factoring polynomials, what I mean by that is it's the process of writing a polynomial as the product of other polynomials. And I know that sounds really weird. It's not the best definition, but basically we've been dealing with binomials, which are two numbers, right? One with a variable and one with just a number is what we've been dealing with right now. Well, factoring is doing the opposite. We've been multiplying them together and getting numbers. Now we're going to try and take them apart and create that multiplication. And we do that with factoring. And you guys are probably familiar with this with the greatest common factor. So when I look at this and I'm asked to factor this, what I'm asking is, what is the largest number that these two have in common? So I look at my numbers here. I have 4x and I have 10. Well, I know that they're both even, so I know a 2 goes into them. But if I pull out a 2, when I factor, what I'm going to be left with is 2x plus 5. Okay? Because you can see basically what I did was I undistributed the number. I pulled the 2 out and I'm left with 2x plus 5. Because 2 times 2x gives me 4x and 2 times 5 gives me 10. Okay? But if I look, in fact, I think that's going to be it. That is my greatest common factor. Okay? So my greatest common factor here was a 2, and I pulled it out, and this is what I end up with. Okay, this is going to be helpful because now we have an equation, or we have something where we got multiplication going on. That's going to be helpful in later problems. But let's take a look at example 3, because example 3, we don't just have numbers in common, we also have the variables in common. So we have to make sure that we're pulling out everything that we need. Because if I looked at this and said, oh, I see that they have a 2 in common, and I'm going to pull that out. So if I pull that out, I get 2 3x squared minus x. 2 times 3x squared gives me 6x squared, and 2 times negative x gives me negative 2x. But they still have these x's in common, so I need to make sure that I'm pulling that out as well. So even though I pulled out a factor, I didn't pull out the greatest common factor. I only pulled out the 2, but they also have an x in common. So this is not the correct answer. It's halfway there, but it's not all the way there. So what my answer should be, or what my greatest common factor should be, is 2x. Because if I look at this number, there's a 2x in this number, and there's a 2x in that number. So when I pull it out, I'm left with 2x, or 6x squared divided by 2x gives me 3x, and negative 2x, and this is a positive 2x, so this is going to be negative 1. And again, I can check my work by redistributing it in and making sure it works. 2x times 3x, that gives me 6x squared. 2x times negative 1, that gives me negative 2x. So I know that my answer is correct here. Okay, so let's look at one more that use these. And I have 3x squared plus x. Okay, so now I see that this is a 3, and whenever there's no number, there's always an imaginary 1 there, right? So there's no factors of 3 except for 3 and 1, and there's no factors of 1 except for 1. So I can't pull out a number, but I do see that they have x squared and x. So in this case, my greatest common factor is just the x, because I can't pull any number out. So if I pull out an x, I get 3x, because 3x times x gives me 3x squared, and x times what gives me x? Well, that's just 1, right? And that's how I know that's correct. So we're going to use this in one more type of problem, and we're going to be solving equations. So again, we're going to combine what we just learned. We're going to use the zero product property, and we're going to factor this. So the equation's asking us, or the problem's asking us to solve the equation by factoring. I look at this side. This side's already equal to 0. So all I have to do is I have to factor this so that I get multiplication going on. And once I do that, I can use my zero product property to solve. So 2x squared minus 4x, I think about that and I say, what are my factors? Well, I see that I have a 2 here, and a 2 goes into 4. I'm good there. Let's look at our variables. I have an x squared and I have an x. How many x's do they have in common? They have 1x. So I know x is a factor, and I know 2 is a factor. So 2x is my greatest common factor. I pull that out. 2x times what gives me 2x squared? Well, that's going to be x, right? And 2x times what gives me negative 4x? Well, that's going to be a negative 2. So now that I've factored the equation, I look at it and I say, oh, I have multiplication going on here. And zero product property tells me if I'm multiplying this times some other number and I get 0, well then either this number is 0 or this number is 0. And again, it's one number because it's in parentheses. Okay, so 2x equals 0, I would divide by 2, but basically, again, we can use zero product property. 2 times some number equals 0. Well, that's just 0, right? And here I need to solve. I'm going to add 2 to both sides, and I get x is equal to 2.